In the last talk, we were talking about architecture in response to climate, and in particular in response to the sun, and how the sun works on buildings and how we can design to optimize the effect of the sun. Today we're going to be looking at several examples of buildings that rely primarily on passive solar design, meaning that we're not using mechanical systems primarily to heat and cool the building, but we're just using the sun. We're using natural forces to heat and cool the building. It's amazing the job that can be done when looking at just those passive solar devices. As in the last talk, today we're going to be looking at warm climates primarily, climates kind of like Texas. And in particular, we're going to be looking substantially today at India. India's climate is maybe even more extreme than Texas, a very, very hot climate. And in particular, today we're looking at projects that were done by Le Corbusier. We've looked at much work by Le Corbusier. Rasmussen in his book, Experiencing Architecture, very fond of Le Corbusier, many projects there. This was a particularly incredible commission that Le Corbusier got. Le Corbusier was at the peak of his career. He easily was the most famous architect in the world in the 20th century. And he was given the commission to do an entire new town in India. Now, he's a Swiss guy. His practice is in Paris. He's in Northern Europe, a very different climate. But as he goes to India, he is inspired by this challenge of working in a very hot climate and working in a place that did not have air conditioning much. At that point, it was very rare to have air conditioning there. And in fact, they really didn't have the resources to mechanically heat and cool their buildings. So he took on this challenge of making buildings that passively heat and cool the building. So this is a country club that he did in Chandigarh. You can just see in that immediate image. It's all about shade. It's all about deep overhangs. It's all about wrapping around a courtyard with a microclimate in there. Some of the things we were looking at in the last talk. But today we're going to be looking in particular at this series of buildings that he did in the Capitol complex at Chandigarh. He did the Secretariat building that you see right there, did the Assembly building that you see right there, and then we're really going to be focusing both on the Assembly building and on the Palace of Justice, which is really the Supreme Court building for this Capitol complex. Now, this was kind of an interesting Capitol because it was right after the partitioning of South Asia. All of this area had been under British colonial rule. When they left after World War II and established the countries of India and Pakistan, then those countries split into states and set up a whole new independent government. And in this particular case here, there were two states adjacent to each other, Punjab and Haryana, that decided to share a capital. So this one capital was for two states, Punjab and Haryana. So their Supreme Courts and their National Assemblies and so on were sharing these quarters together. When Le Corbusier first began to design the High Court building, there was one image that stuck very strongly in his head. He was accustomed to seeing, when he came to India, all of these people with parasols. Now, parasols are used all over warm parts of the world, but of course they had not been used in Northern Europe very much. So walking around in India in this area and seeing people under what we call an umbrella, but they called a parasol, and the word parasol just means, para means for, and sol, S-O-L, means sun, for the sun. It's a little portable sun shading device. So he was taken by this notion of, could I put a parasol over the whole High Court building? And by doing that, could I keep the sun off the building? and keep it much cooler. And in fact, just like a parasol, it shades the building, and then it allows air to move under that, so it flushes out any heat gain that might have been created by that parasol. And then the building actually sits down here completely protected from that. So that was one really fundamental move in the High Court building. The other thing is that he's following the same classic principles that we were talking about in the last talk. Long faces north and south, short faces east and west, fenestration primarily in north and south faces, solar shading. All those principles very, very important to him. But in this case, because the Himalayas ran alongside the site for Chandigarh, and the whole grid of the city was oriented to the Himalayas. So that turned out to be about 45 degrees off of north, south, east, west. So we're not dealing with north, south, east, west faces. We're dealing with, that's the southwest face, that's the southeast face, that's the northwest face. So in most of these cases, he's got a component of south or north and a component of east or west to deal with. Now you can see easily how he's responding to southwest face here. Southwest is maybe even worse than west, because you can imagine a certain time of the day, maybe 2, 3, 4 o'clock in the afternoon. On a summer day, the sun is in the southwest. It's hotter than hell outside. That sun is fairly low in the sky, and the southwest is a very, very vulnerable area to get terrible heat gain at just the wrong time of day. So what does Le Corbusier do? Completely solid on the southwest face. And then he opens up more on the southeast face, and we'll see how he deals with that, and opens up more on the northwest face, and is again using vertical solar shading significantly to remedy the sun on that side of the building. So using a lot of those principles that we were looking at in the last talk, he's got that northwest face there, long face. Most of the fenestration is here, solid on the ends. And you can see how deep that solar shading is. So that any time as the sun comes around on that northwest face, it's blocked primarily by that solar shading, that deep solar shading along there. So the first line of defense is the parasol, keeping the building completely separated from the sun. And there's even a terrace up there so you can enjoy that shady area. The breeze comes through here and flushes out any heat gain. It also is used as a water collection system. There's a part of India that's pretty parched. Water is precious, so they collect the water there and send it into pools in front of the building that are used for evaporative cooling. There you can see that parasol in its kind of purest case. This is actually the lobby of the building. It's an outdoor lobby. Oh, why make it indoors when you can make it outdoors and deeply, deeply shade the area and allow the breezes to cool it. So there you can see the first line of defense is the parasol. When that shade stops doing its job, then the solar shading on the facade begins to take over, that horizontal and vertical sun shading, those huge vertical sunshades in the lobby area there. That water collected here for evaporative cooling, the breeze comes across the water, goes into the building there, and there's through cross ventilation at that point. This is on the southeast face of the building, the opposite side we've been looking at. In this side, the solar shading is out here, and in the space between the solar shading and the actual glass enclosure of the building, that's the circulation route. So people come and go along there. Again, now the circulation is, instead of having to try to condition all that circulation space, it's just outdoors and conditioned by the breezes and by the shading that's there. For the south component of that southeast face, we have horizontal sun shading like that. For the east component, we have deep vertical sun shading like that. And the combination of those two does an effective job of keeping the sun off of that glass, as you can see right there. So on the southeast facade here, again, there's a component of south where we need horizontal sun shading here. And there's a component of east where we need vertical sun shading there. And the combination of that horizontal and vertical sun shading means that on the other side of this brise soleil or sun shading, you can see that it completely keeps the sun off of the glass right there and creates this kind of shady walkway for circulation in the building. All the way through the building, this is in that kind of lobby space where there's deep, deep shadow, these people hanging out there. And then you can see the sense of blazing hot sun out there in India. Oh my God, blazing hot sun. But when you put people in shade and when you let the breezes go through, it actually creates a perfectly comfortable environment in there. So you can see the Palace of Justice it's very much a building shaped by the sun. The brise soleil, the sun shading, the parasol, the umbrella, the outdoor lobby, the outdoor passageways, all of these things are passive solar devices, ways that you can use the building to mitigate the heat of the sun and to make a much cooler environment for the building without mechanical systems. So the second building by Le Corbusier I want to look at here is the Assembly Building. And this is really like the Capitol building itself. This is where the legislators meet, the legislators for Punjab and Haryana. This one is the southeast facade of that building. Again, for the south portion of that, we want horizontal sun shading. And now it's not just a little lid, it's a beautiful sculptural kind of porch that's made there with this big south sunshade. And then it's supported by these very thin planes, which are vertical sun shading for that southeast facade. So again, the architecture is really being made in response to the sun. That same facade, you can see that deep shadow created by that big south sunshade and by the vertical sunshades as well. In this slide, we're looking straight from that would be from the east. And you can see that that morning sun in the east doesn't touch any window in the building. There are windows all the way along here, but they're vertical sunshades that block that east sun. There are windows back here, but they're vertical sunshades that block that sun there. So even low in the sky in the morning, no sun hitting the building. And then this is that killer west facade. And this is actually the southwest face. But we're looking, in this photograph, I'm looking directly west. And you can see that those planes are blocking all of the west sun. The sunshade is actually running completely north-south there and at a diagonal to the building. That building faces southwest, but those blades are running north-south. And so the west side of that blade is keeping all of that west sun out. There you can see that same facade where we're looking from the south, and you can see that now there are the horizontal sunshades keeping the sun off of the glass from the south. But that's all glass back there. Every one of those offices back there has floor-to-ceiling glass, and it looks out and it's got plenty of view. But it's keeping the west sun off by the vertical sunshade, and it's keeping the south sun off by the horizontal sunshade. So you're able to have glass and view and light, but you're able to keep the sun off of the building. And by doing that, you reduce the heat gain. Those have operable windows, so then the breeze can come through and the sun cannot. This is a very interesting, these are actually the tops of the chambers. That's the legislative chamber for Punjab, and this is the legislative chamber for Haryana. Those are the two states that are merging here. Although the building is at a 45-degree angle to north, south, east, west, that slice off of there is directly south. So that we're looking in this camera shot directly at the south face of the building there. And there is this interesting sculptural treatment of that south face. that is actually tracking the sun in the winter time when it's low in the sky. And this is tracking the sun on June 21st in the summertime when it's high in the sky. So that kind of sculptural form is a little essay about the sun. Just one more way in which it is the sun that's shaping the architectural character of that building. Again, just incredible attention to sun shading. This is, you can tell it's late in the evening when I'm taking this photograph. The golden evening light is there, and we're looking from the west. And again, those diagonal sunshades completely keep all of the west sun off of the windows and allow indirect light to come in, but no heat gain from that side of the building. So this is an example, both of these buildings that Le Corbusier did at Chandigarh, where it's the sun shaping the building. And he's making every effort he possibly can to heat and cool the building with the building itself instead of with some mechanical device. Now, this is an ancient idea. I mean, obviously, they didn't have mechanical systems for most of the history of the world. This is Mesa Verde, which is a Native American town in the southern part of Colorado. In this case, they actually found a site that gave them some of these passive solar devices. This huge overhang of the rock here, this is south-facing, and that south-facing overhang allowed them to put their whole village in here where it would get the sun in the wintertime, and it would have shade from the rocks above in the summertime. The southern part of northern Colorado, very similar to the northern part of New Mexico. High diurnal swing, that means it's cold at night but warm during the day. Can be very cold in the winter. You want lots of sun, so that allows the sun to come in at that low angle and warm the place up in the wintertime. But it can be very hot in the summertime, so that shadow keeps the sun out in the summertime. They knew passive solar design even in these ancient Native American encampments here. And then the other thing they're doing is they're using high mass, high thermal mass buildings. And this is another passive solar device where, because they have a fairly high diurnal swing, meaning that it's cool at night and it's warm during the day, this would allow, let's say in the summertime, for a little bit of sun to come in here and heat that up. Sorry, could we redo that again? So step back here. Okay, so another device that is used here for passive solar design is high thermal mass. And what's happening here, in particular in the winter time, is that the sun is coming in at that low angle, and all of this is made out of thick stone walls. And they absorb the heat of the sun all day long. And that's warming the people's homes. But then even after the sun goes down, because this is storing the heat in that high thermal mass stone, it's then re-radiating the heat back to the interiors of these houses all night long. And it's keeping them warm even after the sun's gone down. And when, because of that high diurnal swing, it might be very, very cold at night. So Mesa Verde is sitting there under this natural solar shade and really taking full advantage of the site, helping them create passive solar design. Now, that's an ancient example. For a period of time, let's say World War II to maybe the 1970s, we kind of lost our way on passive solar design, and we began to get very infatuated with mechanistic design. So you could just have mechanical heating and cooling. Why even bother with orientation and fenestration in the right place and solar shading and high thermal mass? Why bother? Just put some air conditioning. And at that point, there seemed to be an endless supply of fossil fuel, and that would just solve the problem. But then in the 1970s, we had the first energy crisis, and that was a real wake-up call, and we began to realize, whoa, fossil fuel may have some finite limits here. And all that fossil fuel burning, we begin to see pollution coming out of that, greenhouse gases, global warming. We begin to see the downside of all those mechanical systems. And in the 1970s, you began to get this infatuation with the idea of passive solar design coming back again. In the end of the 70s, early part of the 80s, I was teaching in Australia. And this was a fantastic project that was done by students at the University of Sydney. It was called the Autonomous House. Can we make a house that just takes care of itself? We don't need mechanical systems. Just insofar as possible, it does not have a negative environmental impact. So everything in the house was made of recycled materials. It had no impact on resource consumption. This is south-facing, and that was a greenhouse where they were growing food, but that was also collecting heat in that greenhouse and then using it to heat the house behind it. There was natural ventilation. There were everything you could imagine to try, these students trying to make an autonomous house. I loved in particular, that was the shower in it. And the students lived in the house on the campus. I stayed there a few days myself. And that shower was amazing, where they used recycled beer bottles. And believe me, on campuses in Australia, they drink a lot of beer. There's a lot of recyclable beer bottles. So they just filled those with water and plugged them so that that created high thermal mass. As the sun would shine on those during the day, it would heat up those bottles, and then that provided the heat for the shower. So you didn't take a shower in the morning, you took a shower in the afternoon when all that was warm, and then even on a kind of cold winter day, it would be perfectly toasty warm in the shower, even though you're naked and you're wet. But that natural gaining of the heat and holding of the heat allowed even something like a shower to be comfortable in the wintertime. Now, these days, we think a lot about this. This is a very important part of architectural design. And we think of passive solar houses very much today. I think in a little more sophisticated way maybe than that autonomous house in Australia. But this is a house in Santa Fe in New Mexico, actually not that far from Mesa Verde. That same climate with a high diurnal swing can be very cold in the winter, can be very warm in the summer, can even be cold at night and warm during the day. This house is just classically designed for the sun. It's got long faces north and south, short faces east and west. It's got pretty much all of its fenestration on the north. We're seeing the north face there, or the south face here, where you have on the north face, there is a little garden that's created by a bluff of the hill there and the house, and that creates a little warm courtyard. In the wintertime, the sun shines in here and warms that up, and you can get a nice little microclimate of warm, toasty space to stay outdoors in the wintertime. On the other side of the house is more the summertime outdoor space, and that's on the north side of the building, so it's protected from the sun. It's got the breezes that cool it in the summertime. So even outdoor spaces are being thought of very much in terms of how can we make just the right thermal control devices. And then with that little courtyard on the south and that terrace on the north, you then can open up the whole house. 40 feet of windows open up there to make just an open space, 20 feet on this side. So on a nice day, you can just be outside almost. And there's nothing more than in Santa Fe, wonderful, fresh, clean, crisp air. And on a beautiful fall day or spring day, or really 8 or 9 months of the year, it's just a very nice climate there for just opening up to the outdoors. And as long as you have the breezes and you have the shade, it's a very pleasant environment. Now, this one, though, is a house that can be tuned so that it can not need heating and cooling for really all but the most extreme times of the year. So the way this works is it has high thermal mass walls here. These are rammed earth walls. And they're made of 4 different colors of local soil. And those are mixed with a little cement, and it essentially makes a concrete wall, but it makes it out of dirt. So again, this is autonomous house. We're not using a lot of resources. We're just using dirt to make those walls. But in the end, they have a very smooth finish like concrete, and they have these beautiful colors of the natural soils that are there. But they're about 18 inches thick, so they're high thermal mass walls. Let's say it's a hot summer day. At night, you would open up all of these windows, and you would let the cool air at night, high diurnal swing, it's probably 60 degrees, maybe even 55 degrees at night. And you let that cool air in all night long. And it cools off those walls so that then they become really, to the touch even, quite cool. Then in the morning when you wake up, you shut those doors up, and they re-radiate that cool back into the house, and essentially it's air conditioning. So that you've captured the cool part of the day and used it to cool the house during the warm part of the day. The same thing happens with heat gain in the wintertime, that sun can shine on those high thermal mass walls, heat them up all day long, and then at night they re-radiate heat back into the house as well. These are those big glass panels that can either be slid out and you have glass through there, or they can be opened up and you have nothing through there. This is looking north, these spectacular views out to the landscape there. The house also has, it really makes an effort to be a completely autonomous house. It has solar collectors, so any electricity they're using, they're manufacturing that electricity too. It has water collection, so that every drop of water that falls on the site is then collected in big tanks under this terrace and is available for use. It has green roofs, so that it's actually sod on top of the roof, and native grasses and wildflowers up there. But that's tremendous insulation that helps the house behave better thermally as well. It's entirely possible to make a house that basically doesn't use resources and energy. The owner of this house has a smartphone where he can see any time of the day, any season of the year, anywhere he is in the world, he can see what the temperature is in every room in his house. And he's very meticulous about kind of keeping track of this. And he can see how much energy his solar collectors are collecting. So I was out there a year ago last summer. I was there in June. It was a very, very hot day, one of the hottest days of the year. There was a museum tour of the house, and there were about 40 people who were in the house for 2 or 3 hours during the day. So this is a real test. This is body heat. It's one of the hottest days of the year. Can the house take care of that on its own? And I happened to have dinner with Rick Torcaso, the owner of the house, that evening. He shows me on his smartphone, even in that extreme condition, his solar collectors actually gave excess energy back to the grid. He did not consume any energy that day. So the point is that you can do passive solar design and really greatly limit the amount of resource consumption a building has. And that works at the scale of a house, but it also works at the scale of larger buildings. There's a Mercedes-Benz Design Center in Berlin, done in 1998. Again, classic design, long faces north and south, short faces east and west. This is Northern Europe, so they need a little heat gain on that west side, like we would not need in Texas. But it's following pretty much all of those principles in a classic way. Very careful design of that south facade and of that window system there. And again, even in an office building, seeing how much you can do without mechanical systems. So these are those windows when on a working day. These are those windows where I shot this one on a weekend when nobody's occupying that building. So they're able to completely close the building off and not have any heating and air conditioning on the weekends. On a weekday, it's got several things working here. This is a south facade, so it's got that classic horizontal sun shading there. But it's even more elaborate than that. These shades that come down are outside the building, and you can see a little bit of them there. And they're able to be controlled when people are working in the building. You can operate that shade. You can pull it down or up as much as you want, and you can even make it open up or close up however much you want. So every individual occupant in there has control over the sun on that south facade. And then there is an override on the weekend that unless somebody's in that office and wants to use it, it controls it automatically. But you can see that there's the general horizontal sun shading. There's that system for individuals to adjust what they want for the inside. There also are operable windows, unusual in an office environment, but you get natural ventilation through ventilation. There's a courtyard in the center of this building, so the breezes can come in, cool the building, go out the courtyard, and ventilate the building as well. So for a great deal of the year, not all year, this is not 100% passive by any means, but it certainly helps to not use mechanical systems for everything. On the west side of the building, this is really an interesting thermal device. I'm taking these photographs in the summertime, and so it's all open, so basically that's not doing a big job in the summertime. But in the winter, each of these panes of glass pivots. This is what's called a jalousie system, and it makes a completely glass wall there. And that then creates a little greenhouse space between the glass wall out here and the window on the inside. It's about 3 feet deep, and it's a little greenhouse. The sun shines in there. It superheats the air in that little zone right there. And number one, it means that if you're heating the building to 72 degrees inside, instead of it being 30 degrees outside that glass, in this space, it might be 60 degrees in there, just warmed by the sun. So again, you're not having to do quite as much heating job. And sometimes they will collect that heat and actually send it into the building so that if it's warm enough, say it's 70 or 75 degree, which in a greenhouse space you can get it like that, and that 75 degree air, they just pump it into the air condition, into the heating system, and it becomes the air they're using to heat the building. Again, it is the building itself that is generating that heat, capturing that heat, and then using it to heat and cool the building. Now, the bottom line of all of this is, these days, this is a huge part of doing architecture, is trying to see how we can use the natural forces of the sun, of the heat generated, of the cycles of winter and summer, of the cycles of day and night, and maximize all of that to really make a building that's far less energy consumptive, far fewer greenhouse gases, far less impact on global warming. Okay, see you next time.